here is a simple question. Why does ChatGPT confidently give you the wrong answer about the company policy that changes last week, for example? And we actually already know a part of this answer. Back in episode 3, we talked about the hallucination, a model predicting plausible text instead of admitting I don't know. And in episodes 8 and 9, we covered the two pieces that make search actually work. The embeddings, which capture meanings, and vector databases, which find the right document in the milliseconds. So, there is the real question for today. If an AI can find the right document, why doesn't it just give the right answer? The gap between finding information and actually using it correctly is what we are closing today. This is RAG, Retrieval-Augmented Generation. And here is the thing that most people get wrong about it from the very start. They think RAG means a chatbot that answers questions about PDFs. That's one use of it, but it's nowhere close to the whole picture. By the end of this video, you will see RAG running quietly behind tools you probably already use. Search engines, shopping apps, banks, hospitals, law firms. And you will understand exactly why it's become one of the most widely used ideas in AI right now. Just 30 seconds of quick recap first, because we have already covered some of those pieces. A language model is a pattern recognition engine, frozen at training time. It doesn't browse the internet mid-conversation, it doesn't see a company's internal files. It works from patterns learned during a training run that happens months ago. So, when it is asked about something newer or something private that was never part of its training, it doesn't say I don't know. It guesses confidently, and that guess sounds like the fact. RAG fixes that with a simple shift. Instead of asking a model, what do you know about X? We ask, here is some information about X. Now answer based on this. Picture it like this. If someone asks you the population of Denver, for example, you would probably answer from memory. And that memory could easily be a year out of date. But hand over this year census page and ask the same question, and something changes. Now the answer comes from reading, not guessing. There is the part that trips people up. That information doesn't have to be a folder of PDF. It can be a live web page, a row in a database, a product listing, a customer's supposed history, a financial filing published an hour ago. The pattern is always the same. 3 steps. Retrieve the relevant information, add it to the prompt, generate an answer from it, but the source can be almost anything. That flexibility is exactly why RAG shows up in so many different places, and we are about to go through several of them. Let's make this concrete with one example before we zoom out. Imagine a company, Tech Corp, with an internal knowledge base of 500 documents, which are specs, policies, compliance files, support procedures, and something else. An employee asks the AI assistant, what is our return policy for damaged items? Step 1. The question goes in exactly as asked. On the second step, step 2, the question gets converted into an embedding. The vector database finds the closest matching documents, often combined with keyword search to catch exact terms like SKU numbers or policy IDs or whatever else. At the step 3, the system builds a prompt along the lines of, here is the relevant information, answer the question based only on this. The model reads it and writes the answer grounded in what it was actually given, instead of whatever it might vaguely remember. Retrieve, augment, generate, same 3 steps every time. What changes from one industry to the next is only the source being retrieved from. That's the part worth really sitting with, because it is what turns RAG from one feature into an architecture that shows up everywhere. Let's go through this properly, because this is where the real value is. Same 3-step pattern each time, retrieve, augment and generate, just pointed at different kind of source. Enterprise knowledge, this is the classic case and one we just walked through. Confluence, Notion, SharePoint, Google Drive, internal wikis, and whatever else. A company's own instructions and policies, searchable in plain language instead of buried 5-folder deep. Customer support, one of the biggest markets for this right now. The company stores different FAQs, past support tickets, and product documentation. DoorDash is a solid real example. When a delivery driver reports a problem, the system first summarizes the issue, retrieves the most relevant past cases, generates a response, and then runs that response through a separate accuracy check before it even reaches the driver. The knowledge based here isn't static document. It is a living archive of every case that's ever been resolved. E-commerce. Here the source isn't documents at all, it is product catalog. Amazon's shopping assistant, Rufus, is the real production example. Someone asks for waterproof running shoes for winter under $150, and the system searches the product catalog plus customer reviews and community questions and answers, retrieves the closest matches, and generates a recommendation grounded in what's actually in stock and what real buyers said about it. AI search engines. When you use Perplexity, for example, or ChatGPT search mode, you're using RAG at web scale. The pipeline is the same. Take the query, search the live web, pull the most relevant pages, hand them to the model, generate an answer with citations attached. Perplexity actually maintains its own index on tens of billions of web pages for exactly this. The source of truth here is the entire internet refreshed in real time instead of the private folder finance, for example. This one's powerful because the data changes by the hour. Morgan Stanley built an internal assistant that gives financial advisors instant access to more than 100,000 research reports, and someone can ask that changes in NVIDIA latest quarterly filling, for example, and the system retrieves the actual report, not a state summary from a model training data. Without retrieval, as we already know, the model would be working from knowledge that already outdated. Let's have a look at the legal field, for example. Lawyers use this constantly. Harvey, a legal AI platform, now used by well over 100,000 lawyers, retrieves relevant case lawyers, statutes, and contracts before the model even answer a question, and every citation traced back to a real checkable source. In law, in an AI that invents a case citation isn't just wrong, it can get a lawyer sanctioned. Retrieval isn't a nice to have here, it is an entire reason the tool can be trusted at all. If we take healthcare, the stakes get even higher. Ambient documentation tools like Abridge listen to a doctor-patient conversation and generate clinical notes, and increasingly this system ground their output in a peer-reviewed medical evidence and established clinical guidelines, rather than whatever the model absorbed during training. Medical knowledge updates constantly. Nobody wants to wait for a model to be retrained every time a treatment guideline changes. CRM and business data, this is something which is underrated in terms of regs. A sales rep asks an assistant to prepare a summary for a specific client. Salesforce's Agentforce pulls the answer together from the CRM records, case history, emails, and call notes, all retrieved and fed into the prompt in real time. This isn't searching documents anymore, it is searching a business's actually operational data. AI agents. This is where it gets interesting, and we got a full episode on agent coming later in this course, so just a preview for now. When an agent is given a task like book me a trip to New York, it doesn't do that in one shot. Before each action, it retrieves something: flight options, hotel availability, your calendar, your budget. Each of those lookups is essentially a small reg cycle. A lot of what people now call AI agents is really a chain of retrieve-augment generate loops with actions attached at the end. We just have mentioned 9 very different fields, but there are a lot of them where regs are absolutely popular and needed. But what we have to know that whatever the field is, It always will be the same underlying pattern every single time. So here is the mental model worth keeping. Most people, when they first hear about RAG, assume it means a way to give a model access to documents. That's too narrow. RAG is really a way to give a model access to any external source of knowledge before it answers. And documents just happen to be the easiest example to explain first. The web is also a source, a database is a source, a product catalog is a source, Ethereum is a source also. If a system searches for something and then answers based on what it found, you are very likely looking at some form of RAG. Why does this spread so widely? A few consistent reasons keeps showing up across every one of these industries. Cost and speed of updates. Fine-tuning a model on new data takes real time and real money. Every single cycle, while adding a new document, listing, or record to a retrieval system takes effect on the very next query. Traceability is also an important thing, for example, in financial part, law and healthcare especially. Being able to point to the exact source behind an answer is not a bonus feature, it is often a requirement for now. And accuracy. Real deployments consistently report large drops in hallucinations once answers are grounded in retrieved information instead of memory, because the model's world is limited to whatever it was actually given. One honest caveat before we close. Grounding a model in real information sharply reduces made-up answers, but it doesn't erase the need for judgment. The model can still misread what it was given, or legal citation can still need a human check before it goes in a filling. RAG changes what the model is allowed to guess about, but it doesn't remove the need of verify. Please remember that always, that verification is still the number one thing we have to do. If you found this video helpful, learned something new, or discovered ways to simplify your workflow, boost your productivity, or even save money, please subscribe my channel and hit the like, because it really helps me to grow and keep digging to discover new things and continue creating more content like this. Also, leave a comment below with your thoughts, questions and experiences. My goal is for us to learn, grow and build real AI expertise together, and your feedback is an important part of that. Thanks for watching and see you in the next videos.